Hey guys, so we finished talking about yet another phase of our data processing, namely serving the data. So it's time to summarize all of this stuff and give you a challenge so you could practice this in action. So let's get started. Alright, so data serving. So let's jump into whiteboard to start summarizing all this stuff. Alright, so what we have here in the whiteboard, this is our diagram that we created at the end of the transform phase. So quickly to summarize what it contains. So far we covered two phases of the data lifecycle. The first one was data ingestion, which was about connecting to all those data sources like files, databases, APIs, whatever, and just dumping the data to a raw layer in a data lake using the native format, JSON, CSV, Excel, whatever. And we know that data factory pipelines, synapse pipelines, or logic apps can be used to do those steps. And then, once we have the data loaded to our data lake, we have to transform it, we've got to clean it. We have to apply various business rules to give some meaning to the data that we just ingested. And we can use various tools to do this, like Databricks, Synapse Spark pools, or data flows that are available in Data Factory and Synapse pipelines, if we don't want to write a code. And effectively, what we'll have at the end of the transform phase is a data modeled usually using dimensional modeling techniques, dimensions and facts, stored as files using this great analytical data format, which is Delta Lake. And to orchestrate the whole process, to organize it into logical steps that are executed one after another, well, we can use either Data Factory pipelines or Synapse pipelines. And great, so this is what we have at this moment. So we have our pure, refined data cleaned that is ready to be used by some consumers. This data is ready to be used as a source for some reports, some dashboards, or maybe we even allow some consumers to connect directly to our data lake and just start to query the data. So that's what serving phase means. So let me write this phase that we are summarizing today. Data serving, or just serve the data. And now we covered two ways of doing this, basically two architectures. So let me separate them. So the first one that we talked about was an example of this modern data warehouse approach. So let me write this down. Modern data warehouse. And in this approach, well, we need to have some relational data warehouse deployed in our environment after the data lake that is used to physically store a copy of our data. And to this data warehouse, consumers would connect. So in our case, what we did, or what we could do, well, is to use dedicated SQL pool, which is a part of Azure Synapse Analytics. So let me draw this. So this is our dedicated SQL pool. And it would work like this. Inside dedicated SQL pool, well, we would just create regular tables that would be basically modeled again using star schema. Usually it is just a copy of the stuff that we have available inside our data lake. But because we want to store the data physically in a dedicated SQL pool, we've got to load it somehow. So we need to implement this step of loading the data somehow. And we'll get back to this in a second. Then, once the data exists in our dedicated SQL pool, well, we can use it to expose the data to our consumers. So let's say that we've got some Power BI reports or whatever tools we use as a front end for showing the data. And the nice thing about combining these two is that, well, dedicated SQL pool, it exposes the data using TSQL, transact SQL syntax, that basically every tool can use. Every tool can understand TSQL. Every tool can speak SQL. And you know already that it is not always the case with Delta format that we used on a data lake. Not every tool can connect to it, so we might need this intermediate layer that would be used as a kind of a translator from Delta to SQL. And obviously we might have some other data consumers that would also be able to connect to our dedicated SQL pool. All right, great. And summarizing this dedicated SQL pool in a few words is, it is this dedicated database engine that is used to handle massive amounts of data. Think of 1 terabyte of data or more. It uses this MPP architecture, massively parallel processing one, that is suited for this kind of workloads. You should remember that it has these compute nodes that can be paused and should be paused if you're not using them, because in case of dedicated SQL pool, you pay for the uptime. And this service is not the cheapest service out there. So remember to pause it, to stop it if you are not using this. And then one thing to remember when creating the dedicated SQL pool is to choose a proper performance tier. And yes, in case of dedicated pool, we have to explicitly provision it. We have to create it explicitly. It is not available automatically after we create Synapse Workspace. And the way to choose performance tier, or the way to choose its capabilities, is to choose a proper performance tier. And performance tier or performance level, it determines various things like number of compute nodes that you would have to make various computations inside our pool. It determines how many concurrent queries can be executed at the same time. It determines amount of memory that would be available for our querying purposes. And finally, it determines the price. So the more powerful our pool is, the more expensive it is. Then, in case of dedicated SQL pool, you have to remember about those 60 distributions. That our data that we store inside dedicated SQL pool is physically split into 60 parts. And depending on the way this data is distributed, our queries might be fast or extremely slow if we don't pay attention to the way the data is organized. And to have impact on the way it is structured, we can use distribution mode at the time when we are creating a specific table. And well, we've got 3 distribution modes. The first one was hash distribution mode that we should use in case of big tables, usually facts, that works in a way that, well, we select a column or set of columns based on which some hashing function will be used, and based on the result, a specific distribution would be assigned. So, for example, we can use this approach, this hash distribution mode, to make sure that data for the same customer is stored on the same distribution, which is great if we know that we will run a lot of queries that work in the context of specific customer. For example, when we want to aggregate sales by customer. And if we distribute the data correctly, then all the data that is needed to satisfy a given query would be available on a given distribution. So we would avoid this data movement, data shuffle that happens when data has to be copied live between various distribution nodes. And we want to avoid this. And finally, when using this hash distribution mode, you should use, well, clustered column store indexes, just to make sure that the performance is optimal. The second way of distributing the data was to use round-robin approach. And in this case, our data that will load to a table is distributed evenly to every distribution, but without any logic. It is just the fastest way to load the data. And it is recommended to use this approach basically for staging tables that we use as a temporary location inside our dedicated SQL pool when we are loading data to it. And maybe then we want to perform some additional transformations on this data, if that's what we want to do, if we still have some additional logic implemented inside SQL pool. And then if we want the insert phase to be as fast as possible, then we shouldn't index our table. No, just use distribution mode and dump the data as fast as possible. Maybe later, once the data is loaded, we might want to index it just to perform some additional logic. And finally, the third method of distribution that we can use is replicated mode, which simply means that every table would be replicated on every distribution. And this makes sense in case of data that is needed basically in every query on every compute node, like dimensions. So that's how we can have impact on the way data is physically stored inside our dedicated SQL pool. And that's important thing to remember, that for those pools, we usually want to store this data in yet another layer in this dedicated SQL pool, just to have this performance boost when querying the data. Now, about this step of loading data to the dedicated SQL pool, well, we've got various options that we've covered in one of those previous episodes. So we can initiate the whole process from the pool itself. We can use either polybase or copy statement. And polybase is a way to query data that lives outside of our data warehouse, like on a data lake. We can query it as if it was a part of our database, as if it was a regular table, but it is stored externally as CSV file, for example. So that's one thing that we could do just by using polybase and those external tables. The other way is to push data inside our pool from some other tool, for example, from Databricks or from Data Factory or Spark pools. So we've got various options. The thing is that not every of those tools can understand Delta, unfortunately. So that's something that you have to take into consideration, that maybe in some cases you might have to switch to a different tool just to perform this load operation, or use a different file format. It's up to you to choose. Then we've got some additional cool stuff that is available in the dedicated SQL pool, like workload management. So workload management is a way to make sure that our queries are executed in a proper way. I mean, that those more important ones are executed faster than those that are not that important, and that they have as much resources reserved as they need. So basically in workload management, we've got those three important terms that you should be aware of. So we've got workload classification, which basically means that, well, whenever we have some request, some query coming to our dedicated SQL pool, we will map it to one of those workload groups based on some rules, basically to reserve, to allocate specific resources and establish importance. So how much memory and CPU this request could use and how important it will be. And to make this work, we would use those, well, workload groups that, for example, we could create for those queries that load the data to our data warehouse. And the second group we could create, well, for querying the warehouse. And then, based on our priorities, we would assign different level of available resources. Then within this workload management, we've got workload importance. So again, this is a way to specify which queries should be executed faster. Because again, unfortunately, not every query, or just to rephrase this, depending on the performance level of our warehouse, we would have a finite number of queries that can be run at the same time. And because in the cheapest version, we've got, I believe, only 4 of them that can be executed concurrently, we might want to indicate which ones should be executed first. And this workload importance, well, that's the way to go. We can define the priority for our workloads, and then those with higher priority would be executed faster. And finally, well, we've got workload isolation, which simply means that we can reserve specific amount of resources for our workload groups, like memory or CPU. So this way, we can make sure that there will be always some part of the resources waiting for queries from a specific resource group. Then we covered this cool stuff of result set caching, which is, well, if we have the same query executed over and over again, then we might want to cache the results. And instead of calculating the result every time the query is received, we would like to take it from the cache and return the results much faster. And this is what result set caching is all about, just to cache the results of our query so it could be faster returned the next time the same exact query is submitted. And finally, well, apart from this distribution that always exists, we could partition our data. If we've got huge amounts of data, then we can think about partitioning. And partitioning, well, it's a maintenance feature. It might improve performance as a side effect, but usually it is treated as a maintenance feature. So for example, it is useful if our business requirements say that, for example, we have to store data from last 24 months only, 2 years, not more. So every month, we would like to just remove the oldest month of data. And we want to do this efficiently without blocking our table, without any negative impact on other queries that might be executed at the same time on our pool. And with partitioning, we can do this by using this partition deletion, switching, and merging. And then we could implement this sliding window scenario, in case of which our dedicated SQL pool would always store 24 months of data, and it would just slide in a monthly basis. And guys, this is not the same that I will be talking about in case of streaming. We'll have a sliding window, there, but it's a bit different thing. And finally, when it comes to security for dedicated SQL pool, we've got several things available. So, well, we can set the firewall for the whole signups that would indicate which IP addresses are allowed to connect. We can set transparent data encryption, that encrypts data at rest, meaning backups, files, data files, or transaction logs. We can set up column-level security or low-level security, which means that while we can define who will be able to read specific columns or rows. And then we can define data masking, which is a way to obfuscate the data as it is retrieved from SQL Pool. So physically this data is not encrypted as it is stored inside the database, but depending on a principal who is querying the data, it might be obfuscated. So instead of a real value, this person would see a masked value. And finally, well, we can classify our data and, for example, indicate that it contains some top secret data, this specific column. So later on, it could be used for various auditing purposes. And basically, this is dedicated SQL Pool, this good old traditional data warehouse, in case of which the data is physically stored in yet another layer. But you might think that, alright, but why? I don't want to pay extra for this possibility to store data. I would like to be able to query the data that lives inside my data lake by using TSQL, but without this additional overhead of this dedicated SQL Pool. And that's how this lakehouse architecture was created. So let me draw it. So we've got lakehouse. And to make it work, well, we would use yet another flavor of SQL that is available inside inside Synapse, which is Serverless SQL Pool. So Serverless SQL Pool. And this pool, it differs a lot from a dedicated one. So first of all, it doesn't store the data physically. No, it is just used to be able to read, to connect to a data lake. So we are not loading the data from the data lake to this serverless pool. We are just querying it. So query the data. But as a result, this data will be again made available for consumers using TSQL. So super cool feature. So basically in this scenario, Serverless SQL Pool is used just as a translator of TSQL to the data format that is used physically on a data lake like Delta. Because serverless, it can speak Delta. Dedicated cannot, but serverless can. So that's one of the use cases when you would like to use serverless, just to implement this lakehouse architecture. Secondly, you might want to use serverless in cases when you want to quickly analyze the data that you have in a data lake. You want to explore it. And with serverless, it is super easy because you just right-click on the file that you want to analyze, assuming that it is on a data lake. And then it would generate a query using open-routed function, great function, and you will see the content of the file as if it was returned from a regular table. And it is super easy to do this, so very good use case. And finally, if you would like to still do some transformations on your data, well, you could do this. Simple ones. For example, you could create a view or implement a logic inside some query and store the data as external table. So it would be stored inside the data lake, not physically in the pool, because here you cannot store the data. And the nice thing about serverless is, well, it is serverless. You don't have to provision it. It is available out of the box once you create the Synapse workspace. And secondly, you pay for what you use. You pay for the amount of data you process, not for the uptime, as it was in case of dedicated. So if you don't have much data to be processed every time, then serverless will be way cheaper than dedicated. But at the same time, it will be probably slower when it comes to performance. All right, so that was this quick summary of those two approaches we could use to serve the data. And obviously, we've got more options available, so we are not limited to use only those two. No, there are more. But from the exam point of view, that's what you have to know. Now, as for the challenge for you to practice this stuff. So what I would like you to do would be, well, to implement this thing. And I assume that you did the second challenge. So you should have some data available. Oh, come on, where is it? You should have some data available in a data lake, like this minifix dimension. And it should be stored as delta. If you did extra stuff, then you would have additional tables as well, like those facts and some other 2 dimensions. But let's say that you have only those minifix. That should be fine. If you don't have it, then you can use any data you have and just save it to a data lake as delta, and it should work just fine. All right, so what I would like you to do would be first, well, play around with dedicated SQL pool and pay attention to price, and remember to pause it because it might be expensive. So here, this is dedicated. What I want you to do? Well, create a table that would store those minifix dimensions, or other table if you don't have minifix. And then make sure to somehow load this data. And I covered multiple ways of doing this. Choose the way that you would find the most useful. And please remember that not every of them supports delta. Then, when creating this table inside dedicated SQL pool, please consider distribution mode. What distribution should be used here and why? Then also please consider indexing. What indexes you believe would be beneficial to the queries that you anticipate would be executed on this data. And then think about workload management, how you could configure this. So workload management. And here I would like you to, well, create 2 workload groups. So one would be for those queries that are used to load the data to the pool. And second one, well, would be for querying purposes. And just to simulate that there is some data consumer that wants to connect to this data using TSQL, just use Management Studio. So this is SQL Server Management Studio, or any other tool that you use like Azure Data Studio. So it would be used to connect using TSQL, and it would be the second candidate to be implemented as a workload group. Then, once it is done, what I would like you to do, well, please create a mask on our table. So mask, for example, on a name column, if you're working with minifix, or on any other text column. So create a mask on a name in a way that, well, it would expose 2 first characters of the name. Then you would have free access, and then again 2 last characters would be exposed. And if this is not enough for you, then optionally play around with column and row level security. Row level security. So that's the challenge about a dedicated SQL pool. Then please do something similar for serverless. So you could compare how they differ. So use the serverless SQL pool. So this is serverless. And here, please expose the data that you have in a data lake. So it would be like this. We want to query the data. And here, what I would like you to do, well, first of all, play around with this open_row_set function. And verify that it can be used to query the delta format. And then encapsulate this open_row_set into a view that could be later used for querying purposes, and that would hide the complexity of these open_row_set internals. And apart from view, what I would like you to do, to expose the same data, but as an external table. So external table. And please make sure to query this data from Management Studio, just to have a proof that it is available for SQL statements. And that's it. So today we just summarized this final stage of data processing about batch approaches. Starting from the next episode, we'll switch to streaming, which will be quite interesting, I hope. So thanks for today, and see you next time. Take care.